Welcome back. We are continuing in 3.6 where we're talking about quadratic functions in general form. This is going to be another example where we're finding the vertex, the axis of symmetry, x-intercepts and y-intercepts. And remember, we're trying to find these things so that we can graph the function. Let's take a look at the x-intercepts first. So we said the easiest way to find those x-intercepts is to factor. So let's take our equation that we have here and get it factored. Again, h of x is y, and so I'm going to put that down this way. So y equals 2x squared minus 4x plus 3. And I need to figure out how I can factor these. If we take a look at this, we have our leading coefficient is not 1, so we can't go straight to the factoring. We are going to use some other steps in between to help us get there. So 2 times 3 is 6. Put that what multiplies to be up there, and adds to be, that middle term goes down here. So we're thinking, what two numbers multiply to be 6 that add to be negative 4? Well, our possibilities for 6 are 1 times 6 and 2 times 3. And I don't see any way that we could add or subtract those numbers so that we end up with a negative 4. That means that this is not factorable. And so later in Module 6, we'll talk about how we're going to deal with these functions when they're not factorable. So for right now, we're just going to leave this alone and find the next step. So we are not going to be able to find the x-intercepts on this one. What about the axis of symmetry? Well, let's use that formula. X equals negative b over 2a. And this will help us find the axis of symmetry, but also the x value in our vertex. So we have our negative b, so the opposite of negative 4 is going to be positive 4, over 2 times 2, which is positive 4, and then 4 divided by 4 is 1. So x equals 1 is our axis of symmetry. Remember, this is a line, and you always need to write it in an equation form. So if you just put 1 down, that's going to be incorrect. It needs to be written as an equation. Now let's use that x equals 1. We know that that's the x-coordinate of our vertex. And then we just need to substitute 1 into our function so that we can figure out what y is. So 2 times 1 all squared minus 4 times 1 plus 3. So I get y equals 1 squared is 1 times 2 is 2. 4 times 1, negative 4 times 1 is negative 4. And then bring down that plus 3. 2 minus 4 is negative 2. Plus 3 gives me 1. So there is my vertex. I've got 1, 1 as my vertex. Now let's find the y-intercept. So for the y-intercept, remember, we're going to let x equal 0 and solve for y. So on this one, we're going to put 0 in place of our x's. So I have 2 times 0 all squared minus 4 times 0 plus 3. And remember, when we do this, it makes those two first terms 0 out, and we're just left with that constant term. So y equals 3. And let's write that as an ordered pair. Right, we let x be 0, and y we found to be 3. So there is our y-intercept. Let's go ahead and get this graphed now. Here's what the graph looks like. Now on this one, we only had 2 points that we were able to graph, and then we had the axis of symmetry. So from the axis of symmetry, we were able to find another point there. However, if that's not enough, if you're trying to graph these by hand, you might want to find another value. Maybe pick another x and see what you can do here. So let's say that we pick x to be 3. And let's put that in here. 2 times 3 squared minus 4 times 3 plus 3. And 3 squared is 9 times 2 is 18 minus 12 plus 3. Here I get 6 plus 3 gives me 9. So my x is 3, my y is 9. So that would be another point on here. So over 3 up 9 we can see is right there. And because of symmetry, we can also find another point on the other side of the parabola, because this axis of symmetry is telling us this point is 2 places away from the axis of symmetry going to the right. So if we go 2 to the left, we'll have another point there. So that's just an easy way to find a few more points on your graph if you need to.